Now the next question is, compare the basic character of 4 compounds are given there. One is ammonia, the second one is methylamine, CH3NH2. It's not methylamine, it is C2H5NH2, it is ethylamine. Then it is dimethylamine, and finally C2H5 thrice N, trimethylamine. What is asked is, compare the base strength of these amines, in gas phase. Two things are asked, in gas phase as well as in aqueous solution. All these being amines, they are soluble in water. I mean, they are soluble in hydrochloric acid. In aqueous medium, they are soluble in hydrochloric acid. And some of these amines are also present in the gas phase. So question asked is, how strong these amines are in the gas phase as well as in the aqueous solution. That is the question asked in 2. Ammonia is the weakest base. As far as the gas phase is concerned, ammonia is the weakest base. Then comes a primary amine, C2H5NH2. Then comes a secondary amine, which is twice this. And the strongest one will be the tertiary amine. So this will be the order. Ammonia is the weakest, primary amine is slightly stronger than this, and strongest of all these is the tertiary amine. So it goes in the same order: ammonia, primary, secondary, and then tertiary amine is that order in the gas phase. This is true in terms of the gas phase. But in aqueous solution, what happens is, the same order is not being followed. However, ammonia is still the weaker base in aqueous solution. This is in aqueous solution. This is not in gas phase. This is in aqueous solution, in aqueous phase. So ammonia is weaker than primary amine. After primary amine, we expect the secondary amine to be stronger and the tertiary amine to be the strongest, but it is not so. The tertiary amine is slightly stronger than the primary amine, and the secondary amine is the strongest of all. So you find this order is slightly reversed in the case of the strength of the amines with respect to the aqueous phase. So in aqueous phase, it is ammonia, a primary amine, then comes a tertiary amine, and the strongest of all these is the secondary amine. Now the question is, why does this reversal occur? Why should it occur? The reason is, 2 reasons have been given for this. Normally when these ions get, when these amine, the lone pair of electrons, the nitrogen gets protonated in all these in aqueous phase. In the gas phase, there is no solution there. There is no solvent there. It is only in the gas phase. Therefore, the same order, this amine strength increases because of the lone pair of electrons. This is because of the inductive effect of the alkyl group. There is only one alkyl group here. There are 2 alkyl groups here. This is actually 2. By mistake, it has been written as 3. It is 2 actually. It is there is only one alkyl group here. There are 2 alkyl groups here, and there are 3 alkyl groups here. So all the 3 alkyl groups will try to increase the electron density on the nitrogen. As a result, the base strength increases. That is true as far as the gas phase is concerned. But in aqueous solution, what happens is, in aqueous solution, the solvent molecules or the various amines get solvated by means of, so this process is known as solvation. Supposing water is a solvent, we call it as hydration. So this gets hydrated or solvated, and the nitrogen is being, the lone pair of electrons is being surrounded by a number of solvent molecules. As the size of the ion increases, it is getting more and more crowded. So in the case of tertiary amine, the steric crowding is most, because there are 3 methyl groups that are attached to nitrogen as against 2 ethyl groups that are attached to a secondary amine. Therefore, there is less of crowding in this, and therefore the proton can approach this in the secondary amine better than in a tertiary amine. Therefore, a tertiary amine is always a weaker base in solution compared to the message that is being conveyed by means of the question is, a secondary amine is a stronger base than a tertiary amine, or the other way, the tertiary amine is a weaker base than a secondary mean. This is to be clearly understood. In the gas phase, it is something different. The regular order is being followed. In aqueous phase, a slight reversal order between these two. These two are okay. As far as these two are concerned, they remain the same. But as far as these two are concerned, there is a small reversal in the order.